Matt, I'll hand over to you and get started whenever you're ready.
Sure. So looks like I'll plan to talk until about 40 past. Okay, so hello everybody. My name is Matt Pollock. I'm a solutions engineer over at NI, and I've been working at NI long enough that this slide looks completely wrong to me in multiple ways. It's been a very interesting 15 years at NI. My main role has been working in various customer-facing roles, but usually centered around help me make my big giant LabVIEW project work. And over the course of that time, I've seen literally hundreds of LabVIEW projects, and more than a few of them have been complete and total disasters. Fortunately, not all of them. And particularly what I want to do here is get a kind of a high level, multi-thousand meter overview of what I see in these different projects that make them successful, and things to consider for what you're doing on your next one that might help you avoid some of the same pain that I've seen other customers run into. And hopefully we can have a bit of a conversation as opposed to me just reading slides to you. To that end, I totally encourage and welcome questions, comments, interruptions, vigorous debates, disagreements, whatever you have, because honestly, that's a lot more interesting and usually much more insightful than just looking at some slide content that I have. That being said, if nobody says anything, I've got enough stories to fill multiple hours over beers to enthrall you all with crazy things I've seen. So I'm going to talk about simplicity, which is something near and dear to my heart because I am lazy. And more specifically, I am strategically lazy. I want to optimize for long-term efficiency. Usually that means I have to put in additional work in a project at the beginning so that I don't have to have that long tail of endless bugs, support requests, changes, confusion at the end. And when I'm talking about simplicity, I'm talking about optimizing it for a number of different dimensions simultaneously. So we want to make it easy to develop, extend, track, debug, test, document, and hand off. You cannot get all of these things at the same time whilst also delivering on schedule to the customer. It is not possible to make everything perfect. As much as we as developers often want to be perfectionists, our customers will not permit it. So it's always a question of what's the right level of effort on each of these dimensions for a particular project to optimize the time that we have most effectively. Ideally, what I can pass off here is minimum low-hanging fruit that you can think of on the next project, and some additional ideas for that mythical time when you're going to have so much free time and no demands or deadlines that you can do whatever you want. Not going to happen, but it's nice to think about. Okay. So first, anytime I'm talking about making projects easier to handle or to make a project go better, I put this slide up every single time because as much as it pains me to admit this, I still talk to a lot of customers that aren't using source control well. And usually the message comes across of I don't have time, or I'm using it a little bit, but not very well. My statement is that if you want to make your life easier, you better have source control involved. And the short answer as to why is that you're going to make a mistake and you're going to want to have that history at some point. And if you are the super programmer who never ever makes a mistake, congratulations. I bet you don't work with other super programmers that never make mistakes. So you still need it. And this is not source control. This is an abomination and should never be done. Yes, I've done it many times, but this is bad. Don't do that. We've all been there. We've all done that. It gets messy. For example, copy final version 2, fix bug. It's never final. There's always another one. We should admit that up front and just get the structure in place to make it possible for us to write software well. Just for my own curiosity, in the chat, is everyone actually using source control these days? Or is there anybody on this call of interested LabVIEW people in a user group meeting that are not actually using source control? Just click the hand raise button if you're using Git. All right. So about a third of the people here, SVN. Couple. Okay. Anybody using Perforce? Not seeing anybody piping up. And I assume we've got a few that are just keeping the versions by making a new folder on disk or by putting the zip file in the network share. If you're doing that and you're being successful, congratulations. That's a challenge to be successful that way. I strongly recommend you reconsider. That being said, since the majority of you mentioned Git, I'm going to go here. Anybody ever had a unpleasant experience with Git merge? This is my favorite picture to describe the pains that you can have with Git merge. I love the internet sometimes. They've got great stuff for me. Especially with LabVIEW, merging and diffing graphically in a Git environment, especially in Git where it's structured around branching and merging frequently and as part of the normal workflow, it can get pretty painful. And I see David in the chat, yeah, you avoid it like the plague. Yeah, me too. And I've actually structured a lot of my development practices around avoiding that. We've got some decent diff and merge tooling these days, but I'm still scarred from several years ago when it just hurt every single time I had to. So here's one of the things that I recommend. If you're doing heavy LabVIEW development, especially if you have multiple developers all touching the same code base, is you absolutely need to spend some time up front with a strategy to avoid those kind of merge battles. Because otherwise, as the project continues and gets into some critical phases, people will be at each other's throats with conflicting changes, and it's going to get a mess. And usually at that point, it's too late to fix it. You're just stuck having to deal with the fallout of your previous mistakes. I know this because I have led several projects that have fallen into that trap, and it has been unpleasant. So first couple of tips is limit any unnecessary quote unquote changes that you've got. LabVIEW, especially if you're changing type defs, really likes to say there's changes all through the hierarchy. This is where the separate source and compiled code option comes in very handy. That's just a quick little help to minimize some of those, but the biggest ones are getting your LabVIEW architecture to the point where it's actually possible to split up the work and have independent changes happening. And that's, again, a step that requires some upfront work. A project doesn't just magically become that way. You have to put it on those rails and guide it in that direction. And similarly, a development process that encourages those good practices. And anytime you actually have to do merges, you better have some testing underneath you to make sure you didn't break anything. Because I'm paranoid when I do my merges, quite frankly. But with these kind of techniques I'll show here, we've actually managed to avoid almost every merge conflict on projects of upwards of 1,000 VIs. And with, I think, 6 developers simultaneously playing in the code base, we've been managed to keep things going. So let's talk a bit about what we don't do. Don't do this. So these are some things that are a problem, and I see them all the time. First is the monolith, the giant VI that has absolutely everything in it and everything is linked to everything else. Random VIs that are just scattered across disk locations on your local drive, in your user folder, on your network share. That's a recipe for disaster when you have that. And also cross-linked code that has external dependencies, especially ones you didn't even know you were bringing into your project. For example, code that depends on drivers A, B, and C, some modified example that's sitting in your computer's example folder, but you're using in your project, 3 old VI packages that you forgot about, one of which got deprecated. It's really important to know what your dependencies are when you're working on these things. And one of the other things I would like to point out as a bad idea, even though it sounds like a good idea at first, is a quote unquote reuse library consisting of all the old code from all of the old projects you've ever done over the past decade, copy and paste it into every new project directory, just in case you might need it for reuse. I've seen variations on that last item a lot, and it usually causes absolutely massive headaches. Usually my recommendation for people that are doing that is A, stop, and B, extract the pieces of that you're actually using and make actual packages out of it. So you can version control it, so you can set that up properly on another machine, so you can actually get changes distributed out. So anytime I see these things, it's usually a symptom of a project that is very, very sick. It's really easy to fall into it because it's less work initially, but it's going to cost you a lot more in the long run. This is a counterexample of keeping a project simpler, even though it takes more work to get there. So clean project and disk hierarchies. Every single piece of code that's used in the project is in the directory in the repository for that project, or an installable dependency. Installable meaning it's a VIPM package that you use, it's an NI package that was created, it's some external third-party installer, but the key is that there's a way to audit what version of it you have on your system and a way to update it so that it can easily match another system. The thing that you absolutely do not want to do is to have dependencies in your project that depend on the source directory of another project or another repository, because then you're asking for trouble because it's dependent on the specific state of an individual developer machine. If you can't spin up a new virtual machine in 15 minutes with every dependency in exactly the right place with exactly the right version, that's a symptom that you're susceptible to problems. If you've got a little script or a VIPC file that describes exactly what someone needs to get set up, that's usually a very good sign. That means you're following really good practices and you're probably thinking about this stuff. Will you have time to do all those things on every project? Maybe not, but this should be something you're shooting for. Of course, all this advice, if you're a single developer working by yourself and you're the only one who will ever see your code, all right, sure. A lot of times it's more difficult to justify spending that additional time. But I'd like to point out that in those cases, usually you're also your own support team. So if a client has a problem, they're going to come back to you and you still have to fix it. And if it's hard to get your system back to the exact same state that your customer or your client has, it's going to be really difficult to support them. And if you can't afford VIPM Pro, every year they usually run a Black Friday sale where it's much cheaper. That's the right time to get a license. I claim that in terms of billable hours that you can save, you're probably going to come out ahead if you actually use it. I'm not trying to shill for Jim Kring, but he and his group have written some pretty good tools. And they also have the community editions that are available. I'll just leave it at that they're very well usable. And if you're building open source software, you can use those, even the more advanced features. Anyway, I'm a big fan of them. It's good stuff. It helps you out. And it's the same thing that we see in other languages and other environments. Like if you're working in Node and JavaScript, you're going to have your NPM packages. You're going to have the listing of the dependencies in a project, and you can just pull them down. It's the same idea. and it's considered best practice industry-wide. And yes, I'd like our entire infrastructure and ecosystem to be fully free and open source. Unfortunately, I also like a paycheck, so I have a bit of conflict of interest here. Okay. So if you aren't familiar with this option, you should be. Separating compiled code from source is an option you can set in a project or in your full LabVIEW environment. But if you've inherited someone else's project and you're making updates, a lot of people don't know that there's a button within the project properties where you can mark any existing items that you already have in the project and separate the source all at once in bulk for the whole project. I personally like to do this because I usually inherit somebody else's code, often from LabVIEW 2012, 2014, whatever it might have been, and that setting's often not chosen.
So Matt, on that one, just to understand that a little bit more, if you pick, this might be a stupid question, but if you pick someone else's code up and then you say mark existing items, that will somehow mark them in the project that they were given to you prior to you starting to develop?
Yes. It would be the same as individually going to the VI properties of every VI in the project and checking that tick box for each VI.
Oh, cool.
It's a way to do it in bulk that a lot of people don't realize is there.
No, I didn't know that. Nice one.
Yep. I found out about it after I wrote a scripting tool to do it, and then one of my friends in R&D said, "Why'd you write that?" So I definitely didn't notice it until I needed it, but I like to mention it here. Other thing that I use a lot for this, especially for cross-linking, is the Files tab of Project Explorer. This is really the only reason I ever use Files tab, and usually I don't want it. But the thing I use it for is to make sure at a quick glance that every dependency of my project is either in the root folder of the project file or below, or somewhere in a standard directory like VILib. If I see anything on there from like my D drive or from my users folder, I can tell really quickly that I just put a bad dependency in there. I probably need to check on that. And if you're lazy, you can make VI Analyzer do that for you. So you can have, there's actually VI Analyzer tests that will check for, do you have code that's in a different directory than what you're expecting? And you can automate that if you're even more lazy into continuous integration systems, so it'll check for you every time you submit your code to source control. So for example, I wrote a little utility over on GitHub that converts the VI Analyzer proprietary, completely useless report file into formats that tools like Jenkins can understand and aggregate for you, which I like a lot because I don't have to do anything at that point. If somebody submits something that introduced a cross-link dependency in one of my projects, it'll immediately show up as soon as they commit it, and it'll show that they just, with this commit, created a new VI Analyzer error. And then I block them from merging and I say, go fix that, and they take care of it. Like I said, strategic laziness. Okay. And hopefully this goes without saying, but no monoliths. None of this. This is the favorite example of spaghetti code that we like to put on slides. I've seen much worse than this, actually, but the code's under NDA, so I can't put screenshots of it up. Suffice to say that I see it often enough that it's worth putting this on here. This is what I'd prefer to see instead. Clean layers, clean segments. And yes, Simon, this is small. I had to fit it on a slide. Like I said, I've got lots of other options, but this is more like what I'm interested in the code bases I work on is very clean top level VI that seems to be trivial, even if it hides a lot of complexity. Because at this point, I've got, 8 different independent loops that would be running. That also means my development team, I can work on 8 independent work streams at the same time without them touching the same files. That's how we avoid those merge battles, is by splitting up the application into smaller pieces, usually in libraries, usually with a separate owner per library. And then I don't have to deal as much with merge battles because I can have separate defined ownership where people don't keep conflicting and writing changes to the same place. And Enrique, yes, I have also seen block diagrams that are extraordinarily colorful because they color the flat sequence structures that they put around everything to group their items. It's terrifying and still haunts my nightmares. Please don't do that. Okay. A small note as well, classes. They're great for splitting code into small pieces, sometimes a little bit too good. You tend to get an explosion of small files because in LabVIEW, every method is a separate VI. If you've ever had to refactor an object-oriented design that is committed to source control, it is extremely painful. And I run into lots of trouble with this. The advice I give my developers on a new project is give yourself 2 versions to just throw away. Prototype them fast, figure out what works, what doesn't. Don't even bother committing them to source control because they are garbage. They are a thought experiment. Throw them away. And then on the 3rd pass through, then actually get into source control because the churn and the level of change is going to be about an order of magnitude lower once you've gone through that exercise. And something that, especially if you're using things like SVN, remember that you also have to commit all of these smaller files, the project file, the LV lib file, the LV class files, as well as the VIs. And I've seen a lot of pain in projects where the VIs are committed, but the owning library or class were not. Check on that. Even better, get testing code in place that will do that as part of a CI system so you don't have to remember. All right. Let's talk a bit about frameworks. So I heard mentioning of Actor Framework on RT earlier. Well done. My key takeaway here is that you should always assume that there's a better higher level starting point than new blank VI. You might want to take off a full application framework like DQMH, Actor Framework, Workers. There's several others. If you aren't at that level, that's okay. Consider then stepping back to project templates, acute message handler. Some of the reuse templates that we've got that you can download. Norm Kirchner, if you've ever seen him present, he'll promote Rex and TLB. Those guys basically provide nice starting points for common applications. And if there's nothing out there that makes sense, build your own. You can extend LabVIEW's project templates pretty easily such that you can generate a new project based on a template and get a copy of everything in a safe sandbox so that you can play with it, break it, do whatever you want. And most customers I work with that are repeatedly doing the same kind of project will typically have built out their own project templates or reuse libraries to accelerate that, because you shouldn't be writing the same code every time. It just doesn't make much sense. And Fred, you have a terrifying example in there with one object that is a monolith class that does everything. Yeah, that's not a solution. Please don't do that. Nice. Yeah, so I'm not going to get on a soapbox and say DQMH is better than Actor Framework is better than this. They all have their place. The key is to at least evaluate what starting points are out there and what makes sense for your project. Most projects don't need Actor Framework. Yes, you could probably implement almost any project using Actor Framework, and once you're up the learning curve for it, it's not that bad. But there's a couple of considerations there as well, I'll get to in a bit, that it's not all about you as the architect and developer. You also need to consider who's going to own this when you're done. And the question was, is there a tool to convert UML to LabVIEW code using LVOOP? I'm aware of the old Indivo toolkits that got subsumed by NI. Those had UML to the by reference design. I haven't seen a great UML to LVOOP. If someone in the meeting does know of that, please post in the chat. I'd be curious to see. It's a gap that I haven't seen a good answer for a long time. Okay. A bit about tracking. I often get asked on my projects, how soon until it's done? Or how's it going? Or, hey, what do you need next? What should we work on next? And oftentimes my response has been, good, I guess, not sure. And that was a problem. And any good project that should be simple to work on, you need to know what you need to work on. You need to track the upcoming development items. You need to understand what you need to do. For me, originally this was Notepad or a whiteboard or Post-it notes, littering my desk with all the things I needed to do. And at one point I tried color coding them, and that was silly. But once it got beyond just me having to work on things, that doesn't work at all. Please tell me your work tracking is not an Excel sheet on the network share. That's generally terrifying. Next level of things is just keeping it in like a OneNote or in some cloud-based tool where I can just keep track of a task list. Eventually, as projects I worked on got bigger, I saw much more value in actual work tracking tools. And these could be packages like Jira, it could be packages like the Azure DevOps suite like I have here, or even just keeping track of GitHub issues is another way you could do it. Having a clean backlog of things that my developers could work on, a clean view of what we finished, and some idea or estimate of how close we are to being done is something that I found increasingly more valuable as I've worked on stuff. Initially, I was like, I'll just use my whiteboard, but it got to the point pretty quickly where I couldn't keep track of things anymore, and it was chaos. So I'd strongly recommend, if you're still in the Notepad or Post-it note or Excel file on network share, take a look at some of the tools that are out there. Many of them are completely free, and they have a lot of very useful features, and not least because I could just make a quick dashboard, and in my weekly meeting with my customer, I could just show them the dashboard and show them the progress without me having to spend any time building any kind of updates or making a fancy PowerPoint or any of that. I'm too lazy for that. What do you all use? I'm curious, in terms of tracking the work items and what you're supposed to be working on a project. So Jira from Neil. Yeah, I've used that many times too. Also used Rally for a while, but and I recently standardized on DevOps, GitHub projects, Core ALM. I don't know that one. Interesting. Spreadsheet on the network share. Nice. Would I name some open source tool here? There's quite a few. One of the easiest ones, you're sticking with the open source ecosystem, is GitHub has built-in project tracking. GitLab also does as well. There's a number of other ones that I can't give a recommendation, but some quick Google searching will give you lots of opinions online from very opinionated folks as to which one is best. Okay. And most of them, like Neil's saying, do have a free tier. They want to get you in on their platform, get you sucked in. That's the model. You can usually find something for your needs without too much trouble. And I'd say that it's certainly worth the investigation, even if you don't have anything yet, because anything's better than the system I used to use, which was chaos. Okay. So testing. I've got whole presentations on testing. The short answer is you're not doing enough. You are never doing enough. You will never do enough. It's much like flossing your teeth. I've never seen a dentist happy with how much you floss, and we always are supposed to do more, and we hang our heads in slight shame. This is standard. This is normal. The key is have a testing strategy, stick with it, and at the bare minimum, have a set of smoke tests to make sure nothing is terribly broken. So it's really easy to get an automated test that checks to see if you have any VIs that have broken run errors. That's the bare minimum for a LabVIEW project. You should have more than that, But that level is something that anybody can get done in an hour or so. And it can save you massively more than an hour in terms of spent time trying to track down issues. Chaos is exciting, inefficient, but exciting. I agree, Simon, it is. Unfortunately, I don't have time for that level of excitement right now. Rather than harping on, and I can, but rather than harping on testing strategies and details of getting testing done, admit that you need to do more testing, understand you're never going to get as much done as you want, focus your efforts on getting something and making sure that the tests always get run. Because tests are worthless if no one's actually running them. They're worthless if nobody's ever actually looking at the results. Start here in terms of getting infrastructure to automatically and with zero effort run and aggregate your results. And then the effort to add one more test becomes much smaller and you're more likely to actually do it than if you try and do something with a big bang approach to get everything done at once. Personally, I like Karaya. This is where we get into more religious debate than technical discussion. So I'm not going to state there's one that you must use. Pick one, use it, and use it all the time. Just make sure that you can actually execute it from a command line interface so you can bring it into a continuous integration system and that it can output results in formats that the CI systems can understand for you. Usually JUnit is what gets used. And Karaya, VI Tester, there's also extensions for NI's unit test framework if you want to use that one that can spit out JUnit results. And this last one is also key. Get in the habit of locking down your pull requests if you're using Git such that you cannot merge your changes in unless all of your tests are passing. It's extraordinarily tempting to turn that off, to just let that code in and you'll fix it later. Don't do that. It's a trap. I've personally been responsible for several failed projects because I permitted that to happen. And then the snowball started rolling and got bigger and bigger and bigger until it was too many bugs, too many issues to actually track down. Do this at the beginning and you'll save yourself a lot of heartache. And also just to note, Karaya does have a test runner that can, you basically just point it at a directory and it'll go in and find any VIs that implement test cases and run them. It also has got some logic to basically remove duplicates such that if you have a top level function that calls 5 subfunctions each with tests, it'll just call the top one and remove all the duplicates. It's fantastic. And I've got for myself in my projects a set of standard project level tests that do things like, do I have any broken VIs? Does everything build properly? Do I have only source code from acceptable locations? And I include those as part of my standard test suites. I also have a standard VI analyzer test config that I put in my projects that make this a lot easier as well. So example time. This is a project I worked on a little while ago. It was a high throughput data logging system. Everything was working pretty well. It was DQMH based. We were pushing data from a PXI system over to another computer. We had a DQMH module that was receiving the UI messages from System Link, and we had a little message handler that was updating the screen with what we needed. Worked great. About to demo this to a customer. I'd actually done some good testing by leaving it running overnight for a stress test, and my memory usage had gone up by 80 gigabytes overnight. Whoops. Anybody guess what the root cause was? It was the queue. DQMH by default, the message handling loop up on the top will just enqueue into the queue that links that to the message handler. DQMH doesn't have a size parameter for how deep that queue gets, which means it's unbounded. My message handler wasn't keeping up with the volume of requests coming in. And since it was a UI update, it should have just been a lossy update. Instead, the queue between them was stacking up massively. So in my case, I needed to add some complexity into the system, which was a helper loop down here connected with a lossy queue. Rather than modifying DQMH itself, I just had it forward down that particular message to a helper loop with a lossy queue and just dropped the updates I didn't care about. This is one where A, I had to add some complexity to make things work. B, we needed a stress test earlier in development, earlier than the day before you demoed to the customer. And then we added a regression test to the CI suite to do this automatically to check for memory leaks. We weren't looking for them, so we didn't see them. You get what you measure. All right, a couple more bits. Before we keep going here, questions, conversation, horror stories, anything that we should talk about here before we keep going? Seeing nothing, I'll keep going. All right. So
I've got a quick one actually.
Yeah, go for it.
Back on source code control, like what's from what you've seen in terms of branches and how you set branches up, what's your sort of preferred approach to that in terms of managing what you do when you've got a feature and all that kind of stuff?
That is a really good question. The best way I've got to answer that is I actually made some training for my own people of how we handle it ourselves. Let me pull that up. So, hey, look, it's a nice color for NI. So I actually standardized my teams on this workflow. Everything that we do first needs a work item attached to it. So we don't make branches on things that aren't tracked. You have to say what you're going to be doing, and you have to be assigned it. You can assign it to yourself if you want. That's fine. At that point, you make a branch, make a new branch from master. Then your work items go to in work, and you do all your work in a small targeted feature branch, never in the master branch, ever. And we target those branches to be as short-lived as possible. We're talking hours to a couple days. If it's open for more than 2 weeks, you have a problem. We want to minimize those merge battles, and one of the ways to do that is to have lots of smaller changes. And generally, if something takes more than a week to implement, you should have broken down that feature into smaller pieces that could be implemented separately.
So does that mean you're releasing to your customer at that frequency as well?
We want to be able to release whenever we have to. Or another way to say it is we follow the methodology that the customer could ask for a demo at any time and we have to be ready for it.
Yeah.
So branches can be unstable, master can never be unstable, ever. And we try to do the work quickly in those branches to get them back to our main branch. It's a modified version of trunk-based development. Developer makes frequent commits to their branch. CI server checks them, makes sure that you didn't break anything. Master branch doesn't get touched until there's a pull request. And that's the point where we do the code review when the detailed CI checks run, and you're not allowed to merge anything in until the CI checks are happy, meaning everything builds without error, all the unit tests and integration tests pass. And we set that up in the source control tool, so it's not a manual thing where we have to check. It's that the merge button cannot be pressed until the CI system says it's good. Pull requests get reviewed. Reviewer says, yep, it worked. We can have some back and forth and maybe some more commits to the pull request if there are changes. Then we merge it on in. And then everybody's happy. We delete the branch. Work item is done. Move on to the next one. And that whole workflow should be done in a couple of days or less. We found that this works really well for us. It may not work great for other groups, but we've seen this scale fairly well.
How will you do this if, as part of your validation, you have to test in production, for example, and you cannot validate so often, so quickly?
That is a great question. We do run into that ourselves. First, I try to attack the problem at the root, which is to have at least a level of ability to test with mocks or simulated pieces instead of the actual production hardware. Second is this will give us the capability to understand, is this a candidate for a release? Not are we releasing it? What I'd normally do at that point is to take, usually it's packages or an installer as the output of the build, and then do a manual test on a physical piece of hardware and run through validation. Ideally, we automate it as much as possible and run the CI agent directly on a duplicate version of the hardware. That's not always possible, especially if that hardware is very expensive. That's when that process, you can't always be fully automated. You might have to have manual checks in there to validate before release. It gets very project dependent for me at that point. But for example, I've worked on projects where it was a €500,000 semiconductor test system. We don't get a spare one of those to play with. The only one is the real one at the customer's site. In those cases, we have to do our due diligence as much as possible to minimize obvious defects, and then work with the customer to test it out on their system only when we've done everything that we could on our side first.
Thank you. I wonder if you can have, I know this is probably not the right way of looking at it, but having two masters, like you have the master that is going into production, let's say, the proper master, and then you have a temporal master where people merge until.
Yeah, and this is where, depending on your organization and your needs are, this could be modified. Typically what we do, and is not in this slide deck that I happen to have available, we'll typically have all of our development in master, but then when we're making a release, we'll make a release branch and then just cherry pick fixes from master into the release branch if we need them for that customer. And the key there is that you would never commit directly into a release branch. We want to keep everything in the same main line. But again, we get into almost a philosophical debate here at that point. I don't want to be prescriptive. I want to say use what works. This is what works for us.
Yeah, thanks.
Matt, there's a question in the chat
Steve,
as well.
Yeah. Don't deliver source code without an export. What do you mean by that? Specifically, I mean don't consume source code that doesn't have an export. So if I've got two projects in two separate repos in Git, I should not be directly calling any VIs from repo 1 in a project in repo 2. Meaning I shouldn't have a dependency in my project for C:\git/project1 if I'm working in C:\git/project2. Instead, I should have a dependency on program files, national instruments, LabVIEW 2020, VI lib, insert name of installed component here from project 1. And the reason for that is there's no way to be sure what the correct state is of the system to test it, to duplicate it, or to deploy it if you depend directly on the source code of another repository. Another way of saying it is they can break you without you knowing it. If you're dependent on a particular version installer from them, you're safe, just install that version. Even if they make changes, they don't break you. And yes, SystemLink is useful, especially for push deployments. If we are, say, building a bunch of packages, NI packages perhaps, and we want to deploy the same software stack out to a fleet of 30 compact Rios that are out there. That's a use case for SystemLink, of keeping those systems synced up in that way. SVN externals to link to another repo. That would be very similar to using Git submodules. I'd say use with caution. The use case there is very similar to locals and globals within LabVIEW. They're really good for a quick fix, but if not used carefully, you can get yourself into tangles once you start using them extensively, especially if you get into dependency cycles or anything where it's difficult to understand exactly which piece you need. My statement with that and for Git submodules is be careful. It can be used if you can be successful if you're using it diligently and you're being very careful with it. If you're just letting people go uncontrolled and add those in anywhere, you're probably going to find that you've injected some chaos that's hard to control. Use with caution.
David, you got your hand up. You got a question?
Yeah, Matt, I apologise if this is an unfair question, so fair warning
fine.
before I start.
Yeah, go for
One of the features that was in Next Gen that I was really excited about was the code became XML rather than a binary file, which meant diff and merge and things like that was, okay, still crazy scary, but less scary. With Next Gen kind of being halted, do you know if there's any plans of ever doing that type of functionality on normal LabVIEW? And as I said, massively unfair question.
It's a fair question. I'll say that having the code be XML sounded good in theory, but having used it, the different merge tools were pretty much just as useless, because just because I can read the text doesn't mean I can understand the impact of a change. The XML had, UIDs everywhere. It had lots and lots of verbose text describing what was being done, to the point where it's still obfuscated from my own understanding. If I looked at the diff, I couldn't understand what it was. Yeah, I could see the text is different, but I don't understand the impact. So for me, that feature actually wasn't as good as it sounded. I was excited about it too. That being said, VI file format, don't expect any changes to it in the near future. My suggestion is work with what we have. We're not likely to get a significant, awesome change to the VI file formats in the near future.
Okay, cheers. I know,
that was
for
one
example,
of the reasons why we were trying for Next Gen, is because we couldn't make changes like that. The challenges are still there.
Yeah. Okay, cheers. Thanks very much.
Yeah, and I'm still bitter about Next Gen too. So I'll also state that we have worked up a number of tools that make that process easier. Let me pull up something, make sure it's public before I do this. Let's see, where's something that's had an update recently? So we've built out some tooling internally to do graphical diffs within pull requests, which is something that we're actually really interested in. I'm going to go and try and find an example of this, if you give me a minute or two, which might look interesting. We'll see. Let's see. Sorry, trying to find a useful pull request, of which they're hard to find at the moment. Yeah, I'll see if I can find it if there's other questions in the meantime. But we've got some open source tooling that will basically take the screenshots of the before and the after for a given commit and actually paste them as images, as comments in the pull request, if you're using GitHub or Azure DevOps or one of those types of systems. So helps for code review. Still doesn't help with merge, but it helps a lot with diff.
Cheers, thanks. Sounds awesome.
I'm a fan. See, we're already at the time we're supposed to stop talking. So, Chris, I'm going to close it off here and state that if anybody's interested or have more questions, I am happy to discuss. I could talk about this stuff for hours. Feel free to ping me and ask whatever you'd like to ask, and I'll cede the floor at this point.